All right, part 2. So let's go ahead and see how we can use the graph of f of x to get the graph of f prime of x. So one thing to keep in mind here, and this is crucial to this exercise, f prime of x, the y values that you get for your f prime of x are slope values. So for each x value on the x-axis of the f prime of x graph that we're going to graph, I need the y value to be the slope of the original function at that x value. So let's start out by looking at where the slopes are 0. So your horizontal tangent lines have slope of 0, and there's 2 places on this x cubed looking graph that I have a slope of 0. I got one right here at this x value. So on my f prime of x, I am going to have a point. Looks like maybe 1 point or negative 1.6 something, maybe negative 1.7. The y value on f prime of x would be 0 because the slope is 0 at that x value in the original graph. The next place where I have a 0 looks like it's just short of a half. So I got the slope being 0 there. So I put a dot at 0 on the f prime of x graph. Now I want to look at maybe the slope at, and I want to go in between. So let's find the slope of maybe right here at that location with -1. And we're just going to, it's kind of inexact science, so to speak, when you're doing this by hand. So I'm going to do something like that. And we're going to count boxes here to get our slope. So I got a little triangle here. Values, I want to get that. And keep in mind that in this graph, every box is just a half step instead of a whole step. So if we come down here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So really a drop of 5 on the y-axis over the course of 1, 2, 3, 4, or 2. So we're really looking at a drop of 10 over 2, which would be 5. So -5 at that x is -1. So over here on my f prime, I would have at -1 a dot at -5 because that's my slope at that point. So that's kind of the process that you're going to be going through here. It's not an exact science with these graphs. You can't be perfect with them necessarily unless you really get crazy, but you can get a rough idea of the slopes by counting boxes. And then at that point where you counted the slope, that's where you put the slope value on the y on your f prime. So let's pick another one here. I don't want to get too steep because my f prime graph doesn't have good slope values beyond -6 to 6. So let's see what's happening at -2 exactly. So we're about right here. Looks like a little slope like that. And we'll count some boxes again. So let's see, coming down, we got 1, 2, 3, 4, 5, 6. So technically down 3. And then 1, 2, 3, 4, 5, 6. So it looks like a slope of -1, or a +1, sorry. So at -2 on the x-axis, we had a slope of +1, so we'd put a dot right there on our f prime. And let's see, I'll do like one more here. So moving over to +1, and this might be a little too steep, but let's see how that works out. So let's do +1. We're roughly about right here. Looking at maybe that slope of the tangent line. That's not quite good. So you can see I'm not, doing this with a whole lot of rocket science precision, but hopefully it's making sense here. You know, kind of the basic idea, counting the slope and then using that slope value to mark our y value on the f prime. So let's go ahead and count some boxes. Maybe I'll bring this down just a little more here. So it looks like we got 1, 2, 3, 4, 5, 6, 7, 8. So it looks like a 4. Again, each box is only half. And then over 2 boxes or 1 unit. So a slope of 4. So at x is 1, we have a slope of 4. So we got a dot right there. And then you could kind of see it almost looks like there's some parabola-like shape that's maybe coming out of this. You know, it's not perfect, but if I can draw on this little thing, you get some basic parabola-looking shape coming out of this for your f prime of x graph. And you could, again, spend many more hours doing this with more precision, but basically the idea again is that you look to your original graph, you pick an x value, you go up to the graph at that x value, you find the slope of the graph at that x value, the slope of the tangent line, more importantly, at that x value. That slope value then becomes the y value at that x location on your f prime of x graph. Now, since the f double prime represents the rate of change of f prime, we can use a similar technique to obtain the graph of f double prime from f prime. So it's basically the same process where I look at my f prime now, find some slopes at different points, and get my f double prime graph built from that. So just like I did before, I'm going to look where would it be a zero slope. And here looks like I got one right there at roughly, let's call that just a little short of -1. So that's right here, we'd put a dot. And then we go back to our not so well drawn graph and we find another value. So let's see here. I'm going to find at 1. I'll put a little tangent line there. And we're going to go up to here and down here. So it looks like we go over 1 unit and then 1, 2, 3, 4, 5, 6. So at 1 on the x, we would have a slope of 6. So 1 on the x will be up here at 6. And in this case, if we were to do 1 more here, and again, this is not going to be perfect by any means, at -2, you know, put a little tangent line there, and looks like, let's see here, so 1, 2, 3, 4, 5, so looks like we dropped 5 over 1, again, just a rough sense, so we got a -5 there at our -2 location. -2, sorry about that. So -2, we had a slope of -5. And if we connect these, you get something like a straight line. And, you know, one of the things that you may be seeing already with these derivatives, if we start with an x cubed, you go down to an x squared, and then you go down to an x. So, you know, conceptually that's working out. But basically, again, the idea is that you get the slopes off the prior graph to help get points on the derivative graph. And you would just keep going and going. Okay, so some terms to be aware of and some concepts to be aware of that come in with these different graphs. And, you know, this overall idea of how f prime and f double prime relate. So when we're looking at the concept of increasing, remember in general, there's a nice little truck pulling up out front there. If you heard that in recording, not sure how good the speaker is or the microphone is, but And just blew some air out the brakes. But at any rate, let's get back to increasing. So I'm getting distracted there. And when you're increasing, let's go back to this original graph here. Remember that you're going uphill as you move left to right. So increasing is here and here. You're increasing. Now, when f prime of x is greater than 0 over an open interval, that means the slope is positive, right? Because remember, f prime is representing your slope, and when f prime is greater than 0, you are positive. And the graph of f of x would then be increasing. So we saw the increasing, I just kind of showed that to start out, but notice that in those places, in between here on the x-axis, or I should say negative infinity up to there, and then from here on out, we have increasing. And then notice on our f prime graph that in those places where it's increasing, we're looking at our f prime being greater than 0. So that matches up. Similarly, when f prime is less than 0 over an open interval, that means that the slope is negative, and the graph of f of x is decreasing. So if we look back at our two graphs there, the f prime and the f of x, notice that everywhere where the, if I can get this to go there, everywhere where the f prime was below the x-axis, where f prime was negative, we have in those x values, in between those x values, right here to here, we have a decreasing part of the graph. Okay, so that's one way you can use that f prime to get an idea of what's going on with the f. Wherever f prime is above the x-axis, your f of x is increasing. Wherever it's below, it's decreasing. So concavity, this is the second derivative. This is where the second derivative comes in. And when f double prime is greater than 0 over an open interval, the shape of the graph of f of x is described as concave up. So think about it as cupped up. If you held your hand like in a bowl shape, that bowl is something that you could actually pour cereal into. It's opened up. So the U is opening up. And notice in this f double prime, looks like we were positive starting from about right here on the x all the way over. And if we go up to our original graph, at roughly that same x, notice that our shape is cupped up, concave up. And then similarly, if f double prime is less than 0, then the shape of f of x is described as concave down. So going back up here, actually from starting down here, you can see everywhere over here our graph of the f double prime is less than 0, all the y values. So from that x over on our original graph, notice that we are cupped down, concave down. So that's basically the main relationships I want you to understand. With f prime, wherever it's below the x-axis, your original graph was decreasing, going down. Wherever it was above the x-axis, your original graph was going up. And then with the double prime, wherever it was, there we go. And sorry about that, having tech difficulties. Whenever your f double prime was above the x-axis, you had cupped up, concave up. And wherever the f double prime is negative, that tells you your original f of x graph is concave down. So this will take a little bit of practice with these, but you will get it. And I'm going to have to do the last part of this as a very short video in part 3. See you then.